Hello and welcome to today's lessons on exponents and powers of 10. Exponents and powers of 10. And today we are going to explore how to work with big numbers in a way that makes them simple and manageable. And by the end of this lesson, you should be able to understand what exponents mean and how they work. And then you should also be able to identify the base and exponent in a power. And then also to be able to use powers of 10 to write large numbers quickly. And then you should be able to convert between standard form and scientific notation. And also, last but not the least, you should be able to apply exponent to real world situations like money, science, and space. Remember, exponents are shortcuts. They save us time and effort, especially when we deal with very large numbers that are difficult to write in full. For example, the distance to the sun or the population of the United States or Ghana can be written quickly and clearly using exponent. So let's get started and take control of these big numbers together. All right, before we start solving problems, let's make sure we understand the words we will be using all the time in this lesson because these are the very tools that help us handle exponent correctly. So the first word we're going to look at is exponent. The word exponent. So exponent tells us how many times to multiply the base by itself. How many times to multiply the base by itself. And when we look at example, 5 exponent 3 means 5 times 5 times 5. So the exponent is 3. And then that 3 tells us how many times you should multiply 5. How many times you should multiply 5. So the exponent really tells us the number of times we should multiply the base to itself. So think of it like this. If you are stacking boxes in a tower, the exponent tells us or tells you how many boxes to stack. That is it. All right. So the next keyword is the base. The base. The base is the number that is being multiplied repeatedly. So in the case of 5 exponent 3, the base is 5. So 5 is the number that is being multiplied repeatedly to the number of exponent it carries. So as seen in 5 exponent 3, it means the base 5 will multiply itself 3 times. This is the number you are stacking or multiplying repeatedly. All right, so let's move to the next one. 3, the power or the power. So a power is the combination of a base and an exponent. This should be well understood because a lot of us has been using these words interchangeably. So the power is the base and the exponent together is what refers to the power. So example, when you look at 10 exponent 4, here is called the power. Here the base is 10 and the 4 is the exponent. Think of a power as a shortcut for repeated multiplication. Instead of writing 10 times 10 times 10 times 10, we can simply write 10 exponent 4. All right. The next word we want to look at is scientific notation. Scientific notation is just a special way to write very large or very small numbers using powers of 10. So for example, if you have a number like 3.2 times 10 exponent 6, which is equivalent to 3,200,000. 3,200,000. So here it is going to be 3.2 or 32 with 5 zeros. The reason why it is 5 zeros is because it's supposed to be 6 times movement. So you stand on the decimal point, then you move to the right 6 times. So if you are standing here, then you move 6 times. 1, 2, 3, 4, 5, 6. So you thereby fill this place or these empty holes with zeros. So we have 0 there, we have 0 here, we have 0 here, we have 0 here, and then we have 0 here. So when you write all together, you see that you have 32 plus 5 zeros, which is 3,200,000. So you see, so from 32, 3.2, sorry. So instead of writing 3.2, instead of writing 3,200,000, you simply write 3.2 times 10 exponent what? 6. So you see, this is what we refer to as scientific notation. It's a big number, which is 3,200,000, but it has been simplified by using scientific notation. It's also a power or a method of exponent that to reduce larger number to smaller numbers. All right, so let's move on. Let's move on to let's continue with the exponent. So now the next thing we're going to look at is that, brethren, by mastering these terms, you will be able to read, write, and solve problems with exponent confidently. Imagine explaining this to a friend. That shows you really understand what we are doing. So that is just by the way for us to understand the key vocabularies, the terms that we'll be using as far as exponent is concerned. So now, what then is an exponent? What are exponents? Basically, exponents are repeated multiplication. Repeated multiplication. Let's start with the basis of exponent. So an exponent is just a way to show repeated multiplication. Okay? Instead of writing the same number over and over again, we use an exponent to tell us how many times to multiply. For example, if we have 2 exponent 3, it tells us how many times to multiply 2. So 2 exponent 3 basically means the base, which is 2, multiplies itself 3 times. It is not 2 times 3 as others have been doing. That is why I am emphasizing on this fact that 2 exponent 3 means the number of times the base multiplies itself. So the exponent tells you the number of times the base multiplies itself. So 2 multiply itself 3 times, and that we have 2 times 2 times 2, which gives us 8. And then 4 exponent 2 tells us that 4 multiplies itself 2 times. So 4 times 4 will give us what? 16. So think of it as a shortcut. Instead of writing 2 times 2 times 2, you write 2 exponent 3. This saves time and space and makes calculations faster. All right, so how to say exponent? How do we read exponent? 5 exponent 3 is read as 5 to the 3rd power, or 5 cubed. 5 to the 3rd power, or 5 cubed. And then 7 exponent 2 is also read as 7 squared, or 7 to the 2nd power. 7 to the 2nd power. Notice that the exponent tells exactly how many times the base is multiplied by itself. This is the foundation for everything else in this lesson. And if you're able to understand this, believe you me, you'll be able to grab every concept that you'll be talking about in the next, in our next slide. All right. Powers of 10. The fast way to big numbers. Powers of tens are extremely useful for working with large numbers. So let us look at the examples here to understand how this works. So if we have 10 exponent 2, it means 10 multiplying itself 2 times. And that also means that the number of zeros to add should be equivalent to the exponent that the base carries. That is, we are dealing with powers of 10, meaning numbers 10 as the base with its assigned exponent. Okay, powers of 10 just means that 10 will be the base and then with it attached or assigned exponent. So 10 exponent 2, the basic and simple way of getting the answer is writing the number, the exponent, then the number put on top as the exponent, write zeros to that equivalent. Write 0 to amount to that number. So 10 exponent 2 means you write 1 with the 2 zeros attached. 10 exponent 3 means you write 1 with 3 zeros. 10 exponent 4 means you write 1 with 4 zeros. So the number of exponent when it comes to powers of 10, where the 10 becomes the base, or the 10 is the base, it is easy to remember by just adding the number attached to the as the exponent. You write zeros to that number, then you are done. All right, so do you see the pattern? The exponent tells us how many zeros are added after the 1. So 10 exponent 5 means 5 zeros, and 10 exponent 8 means adding 8 zeros. This is pretty simple and easy. Now let's look at real world examples. So we have, let's say, a space. You know, the sun is about 1.5 times 10 exponent 8 kilometers from the earth. That is around 150 million kilometers. You see, but it is just summarized and written simply as 1.5 times 10 exponent what? 8. So you see that this is basically simple way of writing 150 million kilometers. And then the population, let's say United States of America or Ghana's population being approximately about 3.3 times 10 exponent 8 people. So that is around 330 million people. So by not writing 330 million, even this one, I short it with the words. So assuming you are writing and adding zeros, it's going to be 330 plus additional 6 zeros. So you see, writing these long numbers, you simply put it in the short form as 3.3 times 10 exponent 8. Then the next thing I want us to consider when it comes to the real world examples of using exponent is the money. The money. So a billion has 1 times 10 exponent 9 dollars. So that is 1 billion. But you see, it has just been written simply in exponential form as 1 times 10 exponent 9. So you see that by using powers of 10, we can easily write, read, and work with numbers that are otherwise very long. Notice how much easier it is than counting all these zeros. You see? So this is a very lucrative way of putting numbers simply without stress. All right, so let's move on to look at exponent versus standard form. When we say exponent and standard form, what do we mean? So we are coming to compare standard form and power form or power form to understand why exponents are so helpful. So when we talk about standard form, this is the normal way to write numbers. The normal way to write numbers. For example, we have 1,000, 10,000, 20,000, 300,000, 4 million, 5 million. These are the normal standard form we are talking about, as you can see on your screen. But writing these numbers works fine for small numbers. So when you are writing 200,000, I think these numbers are less, so you don't find any stress writing them. Now, the problem is it becomes difficult to read and difficult to write if the numbers becomes large. So people tend to make mistakes, okay? And then it's easy, it's very hard to read, and then it's easy to make mistakes, because if you're unable to add the number of zeros today to read, you will be losing the value of that particular number or digit you are talking about. So that is why it is very, very important to learn about exponent using the power form. Okay, so now instead of writing 1,000, you say 10 exponent 3. And instead of writing 10 million, you say 10 exponent what? 7. So you see, remembering 10 exponent 7, 10 exponent 3 is of much easiness. It is much easier for us to remember than writing 10 million. And if you are not careful to add the last 7th zero, then it means that the value of that number or that digit is wrong. So think of it like this. Exponents are shortcuts that help mathematicians. It helps scientists and engineers handle huge numbers efficiently. So that is how beneficial it is for those who are dealing with large numbers. Billionaires, okay, engineers, scientists, they find it easy to use than to be mentioning big numbers, which of course you cannot keep off head. All right, we move on. So how to write scientific notation? Remember, we look at scientific notation, how to write them. Scientific notation is a useful method that we use to write very large or very small numbers compactly. Okay, let me show you the steps. Now, the first thing to do is move the decimal place, or the decimal point, sorry. Move the decimal point. Now, place the decimal after the first non-zero digit. So when we are talking about non-zero digit, for example, we have 45, we have 4,500,000. Sorry for the comma placement. We have 4,500,000. So if you want to, write that in a scientific notation form, you have to what? Follow these steps I am coming to tell you. Now remember, 4,500,000 is in a standard form. So we are now going to what? To write them in the scientific notation form. And the first step to do is to put the decimal point after the first non-zero digit. So for example, we have 4,500,000. So you put it in between the 4 and the 5. In between the 4 and the 5. So you place the decimal point here. Okay? In between the 4 and the 5. So that is the first non-zero digit. All right. So now count the jumps. Count how many places the decimal moved. So here you stand here, then you move 1, 2, 3, 4, 5, 6. Okay? it moved 6 times. Is that okay? So I'm so sorry, I have, okay, so there's supposed to be another 0 here, sorry. So we're supposed to move 7 times. All right, it's supposed to move 7 times. So we have how do you call it? 45 million. So that will be 45 million. Sorry about that. That will be 45 million. So you stand in the middle of the 4.5, then you move the decimal point 7 times to the last 0. That is the second step. Then we now write as a power of 10. The number of times you move, you write that as a power of 10. So combine the number with 10 raised to the power equal to the number of jumps. So because here we have moved 1, 2, 3, 4, 5, 6, 7 times, we write 4.5 as the base, as that number times 10 being the base with the number of jumps as the exponent. So we now have 4.5 as a separate number. Then you put times in between. Excuse me. You put times in between, then the 10 being the base, and then 7 represent the number of times we jump. So this is how we write standard form numbers, or numbers in standard form, in a scientific notation form. So we now have this as our final digit in scientific notation form. So remember, the first word is 45 million. This is it. So the first one is the 45 million, and then we move. You place the decimal point after the first non-zero digit, which is between 4 and 5. Then you move from that decimal point to the last 0 by counting the number of jumps you make. So we move from here 1, 2, 3, 4, we have 5, we have 6, we have 7. So we move 7 times. So you now write your 4.5 being the first digit or the first number, then times 10 being the base. Remember the zeros. We are talking about the 0, how to represent the zeros. So the 10 being the base, and then 7 on top, telling us that the 10 or the number of zeros to be added should be equivalent, or the number of times we move to be equivalent to the exponent that the base 10 carries. I hope it is clear. Okay. All right. So let's move on to the next part of this lesson. All right. So this is extremely useful in science, okay? That is why we term it scientific notation. This is very useful in science, in astronomy, and in finances, because it saves space and prevents mistakes when writing very large numbers. All right. So what is the meaning of 10 exponent 4? Let's try our hands on this. You can pause the video and then work it out and then select the right answer. Okay, so let's proceed. Let's really understand what 10 exponent 4 means. Some students confuse it with addition or multiplication. So when you see 10 exponent 4, they may say 10 times 4. That is what some do say. So they mistakenly do it fast. Oh, I know it. Then they times the exponent with the base, giving us 40. Is that actually correct? Some of them thought it is an addition. So they end up adding the 10 4 times. So 10 times 10 plus 10 plus 10 plus 10, giving you 40. Sometimes these do confirm the multiplication method and then the addition method, which according to them confirms the answer. Because when you see 40 here and then 40 here, it tells you that yes, of course, that answer might be correct. But these methods are wrong. Now let's look at another one. Some also thought that the exponent will be multiplied to itself by itself the number of times of the base. So the exponent being 4, they tend to multiply it 10 times to itself, giving you 10,000. So that also, when you do it and compare to the last method, which is 10 raised to the power 4, some also believe that the right way is multiplying the base being 10 by itself 4 times, which is the number of equivalent to the number of exponent. So 10 times 10 times 10 times 10, which also gives you 10,000. So considering this fact, others also use this method. But which one is the right way? You see, the right way is the last one. 10 times 10 times 10 times 10, which is equal to 10,000. Which means 10, which is the base, will multiply itself 4 times. I hope that one is clear. So notice that the exponent tells us how many times to multiply the base to itself, not add or multiply by the exponent. This is a key point to remember. Okay, so let's move on to look at how to practice or how to apply this in our daily life. So now that we understand exponents and powers of 10, let's practice applying them to real life situations. Okay, so if you have 1,000 as 10 exponent 3, 10,000 as 10 exponent 4, use powers of 10, simply large numbers like maybe 100,000, which is around 10 exponent 5. And then we are also able to learn how to convert to scientific notation. That is 45 million. We converted into 4.5 times 10 exponent 7, which of course we did earlier. So applying these things in our real life, you're going to think about your age, the population of your town, or the distance to the moon. How will you write these numbers using exponent? Okay, how are you going to write these numbers using exponent? But the more you practice, brethren, the more confident you become, and the more you practice, you understand exponent. Exponents allow you to control huge numbers easily and make calculations faster and safer. So what I want you to do is to keep practicing. You've got this. Now you can what? Read and write exponent. You can use powers of 10 to simplify large numbers. You can convert between standard form and scientific notation. Apply these skills to real life situation. Keep practicing, because this is the key. This is the key. And thank you so much for joining me in today's lesson on exponent and powers of 10. You've learned how to read and write exponent and a whole lot of things today. I want you to practice. Write at least 5 numbers in powers form or scientific notation form, including very large numbers. Check your work. Make sure your exponent match the number of zeros in the original number. Teach someone. Try explaining what a base and exponent are to a friend, siblings, or parent. Teaching helps you remember. And if you are able to do this, you will realize that you are 100% close to be an exponent expert. So engage in online. You can decide to watch this video over again and again. And then if you are watching this right now, I want you to like, I want you to subscribe to the channel and leave your comment telling me your favorite examples from today's lesson, and then keep practicing. Observe numbers around you. And remember Big numbers are easy when you know the power of 10. I'll see you in the next lesson. Take care and God bless you. Bye bye.